Hey everybody, we're working on the 2017 Mcas. So this is a few years old. This is one of the last of the older versions. We're working our way through it. So if you're watching this, make sure you've already tried these problems. You'll find the PDF to this in the video description, and you can check your answers at the end of the PDF because all the answers are listed there. Um, so yeah, all right. So this is this open response question here. What do they call it now? Constructed response or constructed answer? They changed the name of it. All right, here we go. So triangle KLM is shown on the coordinate grid below. So we have the triangle here. And this is back when you had to copy it. Nowadays it's going to be digital. But anyway, copy the axis and the labels and the triangle KLM exactly as shown on the grid in your student booklet. So we're gonna do something a little different. We're gonna use this grid because I don't have an extra grid right now. So let's do it that way. On the grid you copied into your student answer booklet, draw a triangle K prime, L prime, M prime, the image of triangle KLM after it's been translated 8 units to the right and 3 units down. So for this part, it wants us to apply a translation to this. And you remember a translation is a shift, okay? Let me zoom in here so you can see that. That looks like another word. That looks like a bad word. Shift, okay? So translation is when you shift something. So we're going 8 to the right. So it's going to be x plus 8, and then 3 down, and then y minus 3. That's what we're applying here. Okay. You don't need to use that algebraic format because we can just graphically do it. So we're going 8 to the right. So we're just going to count. These are all by 1. So 1, 2, so we're going 1, 2, 3, 4, 5, 6, 7, 8. And then we're going 3 down. 1, 2, 3. Okay. And that's going to be K prime. And we're going to go 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3. And that's going to be M prime. And we're going to go 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3. And that's going to be L prime. Okay? And we'll connect these. And we've labeled the vertices rather. Okay. All right, there we go. There we are. Let's make sure we followed the directions there. In the last video I kind of made a mistake on one of them. So on the grid you copied it in. We drew the triangle K prime, L prime, M prime. Yep. The image of triangle has been translated. Be sure to label the vertices. All right, so part A is all done. Okay. On the grid, draw a triangle K double prime, L double prime, M double prime. This is the image of K, L prime. So this is going to be the image of now this. So this is now becoming our pre-image, okay? All right. After it's been reflected over the x-axis, be sure to label. Okay, so we're going to do a reflection. Now remember, a reflection is a flip. Actually, we'll use a blue marker for this one. It's a flip, okay? So now the rule, when you reflect over the x-axis, is going to be xy becomes x opposite y. Now people always think this means negative y. It doesn't mean negative y. It means you just change the sign. And if you don't remember the rule, it's okay. All right, so what you could do is you could write down the coordinates and just change the sign of the y value, which is very easy to do, or you could just count the distance from the point to the line of reflection and then go the opposite direction. So that's what we're going to do here. So, because a lot of folks won't remember the rule. So what we do is we know it's going to flip, it's going to fold on itself here. This is the line of reflection, this is the x-axis. So for this problem, we need to know what the x-axis is. Right, it says x-axis, so we know this is the x-axis, right? Hold on, I keep zooming out too much. Here's the x-axis, so that's our line of reflection. This is our pre-image, so now we're going to reflect it. So we're going to count the distance from each point to the line of reflection, okay? So this is 2 away, so M prime is here. We're going to go 2 away the opposite direction, so M double prime is going to go there. So that's going to be M double prime. K prime is, let's see, 1, 2, 3, 4, 5. So it's going to go 5 the opposite direction. So 1, 2, 3, 4, 5. And that's K double prime. L prime is here, it's 1 away, so L double prime will be 1 away down here. Okay? Now we're going to connect these. Okay? All right. Now let's just make sure it's not asking us to, no, it's not asking us for the coordinates. So that's it. So you'll notice these are all congruent. These are what we call rigid transformations where they preserve congruency. All right? Let's look at part C. Is this only a 3-parter? It's only a 3-parter, okay. So far so good. So again, you know, if you don't remember the rule, the reflection rule, no big deal. Just count the distance from the line of reflection. Okay? All right, let's see what part C is asking us to do. It's hard to zoom in so you can actually read it, but also, you know, fit it. All right, point P, which is XY, lies on triangle KLM. So this is on the original. Point P double prime is the point of P after the transformations from part A and part B have been completed. Okay, so point double P would be somewhere on the blue triangle. Okay, write an expression that represents the y coordinate of point P double prime in terms of y. Show or explain how you got your answers. Okay, so this is going to require somebody to know the reflection rule and somebody that can express the translation algebraically, which we already did here. So we actually kind of have a head start of this. We know that, so we're just going to do the y. So we start here with y on the black triangle, right? And to go from the black triangle to the red triangle, we have to subtract 3 from y because that represents the shift downward. So we're going to say y minus 3, okay? That's how we went to the, I should probably do that in red, but yeah, hold on. Let me redo that. So we start here with y, the black triangle. Then it becomes y minus 3, right? That's going down. And then we change its sign. So it would actually become negative y minus 3. So whatever we did here, we then change its sign because it represents flipping over the x-axis. And that's it. That's the expression that represents the y coordinate. Okay? Pretty straightforward. All right, so this problem, you know, the first 2 parts, I think most people can get those done if they've had any experience with transformations. The third part definitely requires a more advanced knowledge of how it works. So if you can express this algebraically and you understand, and you remember the reflection rule, then you should be fine for part C. Okay. What else we got? Number 18. Okay. First 4 terms in a geometric sequence are shown below. We're going to run out of time here? I'm about to run out of time, guys. So I'll probably be able to do this problem, and that might be it. Yeah. Yeah, probably. All right, so the first 4 terms in a geometric sequence are shown below. All right, so we have 1/18, 1/3, 2, 12. All right, so we're trying to find out what we did to get there. So we're trying to find out what this term is, okay? And you'll notice we're actually multiplying here. What's happening is we're multiplying by something. If you're not sure what you're multiplying by, you can just take a term and divide it by the previous term. So 12 divided by 2 is 6, right? So this divided by that is 6. And 2 divided by 1/3, let's try that. So 2 divided by 1/3. And when you divide by a fraction, you're actually multiplying by its reciprocal. So that's actually 2 times 3/1, which is 6. And again, the same thing's going to be over here. So 1/3 divided by 1/18 is actually going to be 1/3 times 18/1, which is 18/3, which is 6. So we're multiplying by 6, okay? So what's 12 times 6? That's going to be 72. Yeah, 72. 72 is the answer there. I think about that. Okay. And then number 19. How much left in session 1 do we have? No, we're probably not going to finish session 1. We'll probably get to, we'll probably get to the next open response that's cut off there. Okay, the line graph below shows the total number of miles traveled by a car during a 7-year period. Okay, so as you can see, the person that owned the vehicle, this is how many miles they're accruing on their vehicle. They've had it for 7 years. Okay. Based on the line graph, between which two consecutive years was the rate of change in miles traveled per year the greatest? So rate of change is the slope, okay, and you can tell the a higher rate of change is going to have a steeper slope, right? So this is obviously not the greatest rate of change, right? You can tell here, this is one of the more, it looks almost flat, right? Now you can estimate, excuse me, from 55,000 to 60,000, they went from a little over 55,000 to a little more over 55,000. Not a lot of change here. Here, they went from 45,000 to a little over 55. So they went about, a little over, maybe around 11,000 or so. But it's fairly steep. This looks awfully close to this. These look very similar, right? And you can tell because it's a steeper slope, right? These are pretty similar. This is slightly slower. You can tell this only went up by 5, whereas this went up by, let's see, 35 to 45. It's about 10 or 11. So this is out. This is out. These are close to each other. Look at this one down here. They went up by 5,000. That's out. So our highest one right now looks to be around 11, 10 or 11. All right, these two right here. Let's look at this one. This one, let's see, from 5 to 15, so that's 10. That's very similar to these two. It looks almost identical, right? However, look at this one. This is noticeably steeper than that, right? It goes, you can tell, right? So from 15 to 30, that went up by 15, right? So 30 to 15 went up by 15 right there. And they're all an exchange of 1 in 1 year. So this is going to be our steepest slope right here. This is our highest rate of change. But you can tell vertically by looking at it, right? So I actually have to tilt the ruler just to line it up, right? Whereas this one you can actually, it's a little tricky. You could do it with a pencil or pen on a screen. So what two consecutive years between the second and third year? Okay, and that's it. So the next video we do will probably be a longer one. It's going to hit the next 2 open responses, and that'll be the end of session 1 of the 2017. So just a quick review. Let's see here. Yep. So the open response was all about transformations, geometric sequence, being able to work with one of those, and rate of change. That's it. All right, hopefully that was helpful. Thanks, guys.